Sometimes when you're making a solution or you're buying a certain solution at the store, you're going to notice that they are in certain percents. It gives you a percent of solution. And so we need to be able to understand what that means so that you know what it is that you're buying. There are two different ways that these percents can come in. They can be percent by volume or they can be percent by mass. Percent by volume is going to be the volume of your solute versus the volume of your total amount of solution multiplied by 100 to get that percent. And normally you're going to see these with liquids. When you have two liquids that you're mixing together, you would know the total volume of solution and what the volume of your solute is. So let's take a look at how we could solve for some percent volume problems. If you ever look at ethanol alcohol, and we've used alcohol in class before or for different things, you're going to notice that it's not 100% alcohol, it's mixed with water. And if we wanted to know what our total percent of ethanol was in that solution, we could use this particular equation. So let's say that we had 85 milliliters of ethanol and we've added water to it, so it's not 100%, it's diluted, and we have a total of, and the total volume is 250. Okay, so it's not just 250 milliliters of water, it's total solution is 250. So our percent volume says that we need to know the volume of our solute, which is 85 milliliters, and the volume of our solution, which is 250. And we want to multiply that by 100 to get a percent. And so two significant digits and some math later, we have 34% ethanol is what you're down to. If we looked at another one, hydrogen peroxide is one that you can see this a lot, is not 100% hydrogen peroxide. It's definitely a lower grade solution, what you buy at the store in your pharmacy area there. So we have 3% hydrogen peroxide, and we want to know how many milliliters of hydrogen peroxide is that really when you have a 400 milliliter bottle of this solution. So our percent volume total is the 3%. Now when we're solving this, we may want to get the percent out, to leave the percent out of the formula so that we don't have to worry about that multiplying by 100. So we can convert this to 0.03, sorry, it's just moving the decimal to get rid of the percent. The volume of your hydrogen peroxide is what you don't know, and the volume of your solution is 400 milliliters. You have a 400.0 milliliter bottle. So to solve this, we're going to look at our percent volume is equal to the volume of your solute over the volume of your total solution. And we know that we have 0.030, and that's equal to the amount, the volume of your solute, which is what we don't know. We're trying to figure out the milliliters of hydrogen peroxide. But we do know that our solution is 400.0 milliliters. So if you cross multiply, the volume of hydrogen peroxide is 12. You only have 12 milliliters of hydrogen peroxide out of that 400 milliliters. So it's very, very diluted. Now we can also do percent by mass, which is very similar, only we're looking at the mass of the solute divided by the mass of our solution, and again multiply by 100. And this is more convenient when your solute is a solid. So when we, for instance, dissolve salt into water, then we normally would do percent by mass. So if we take a look at this one, we want to know how many grams of solute are needed to make 2,000 grams of solution, and this is glucose in water. We have a percent mass of 2.8%, or we could convert that to 0.028 just to get rid of the decimal, to get rid of the percent. The mass of our solute, which in this case is glucose, is our unknown, but we know that the mass of our solution is the 2,000 grams with a period at the end. So we have 4 significant digits there. So percent by mass is equal to the mass of solute over mass of solution. And we can plug our numbers in here, and we're going to notice that we need to cross multiply again because we have x over 2,000 grams. So if we cross multiply, we are going to have the mass of our solute, which is glucose. 0.028 times 2,000 will give us 56 grams of glucose, is how much we would need in order to have that 2.8% by mass. Lastly, you are going to be doing this one on your own. This is actually really similar to the last problem on this previous screen. It's asking you for the grams of solute. You are given the grams of solution, and you're given the percent. So it's just a matter of using different numbers, but the problem remains the same. If you have any questions on how to do this one or how to set it up, please let me know, but I'll walk around and check this one in class.